Hey there, welcome back to my channel. You're watching part 11 in the video series that I prepared, in which I present you with the content of my TOK essay titled Deconstructing the Human Condition, again the full text of which you can find on my WordPress blog, which is erikvandepoel.wordpress.com. In this episode I'm going to read to you a section of Chapter 10, which is about mathematics. Here goes. 2 and 2 equals 4. Mathematics has often been described as the science of rigorous proof. As a subject of intense study, it seems capable of both charming and alarming in equal measure those exposed to its workings, and I personally used to be one of the alarmed ones. From casual observation, one might easily be led to believe that mathematics primarily concerns itself with identifying and harnessing the abstract patterns that underlie reality at large. The mathematical evidence hinting at the very existence of these orderly patterns might explain why humans in general seem to derive such deeply felt stirrings of certainty from mathematics as an area of knowledge. However, and especially for those privileged enough to have mastered a specific level of fluency in the formal language of mathematics, like Henri Poincaré for instance, not only does there appear to be actual practical value to be had from it, mathematics, but a fundamental appreciation for its formulaic artistry in providing a most rewarding and emotionally satisfying experience too. To many a poetically oriented mathematical mind, the language of mathematics is expressed and readily observed in the natural world in the widespread occurrence of symmetrical elegance and aesthetically pleasing geometrical shapes in the countless living organisms inhabiting our biosphere. To investigate this claim, you are invited to research the existence of the Fibonacci sequence in naturally existing shapes and systems. The Fibonacci sequence is a mathematical sequence popularized and recently further immortalized in Dan Brown's book, The Da Vinci Code, by the 13th century mathematician Leonardo da Pisa. Leonardo da Pisa is also credited with the introduction of the Hindu-Arabic 0 to 9 numeric notation into Western thinking and computing. A curious trait of the Fibonacci sequence reveals itself as you progress higher up into the sequence, where two consecutive numbers divided by their respective numerical values ever increasingly approach the legendary golden mean, which approximates 1.62. Certainty, practical value, and sex appeal mixed into a potent cocktail have proved to be capable of ensuring a lasting attraction from the birth of Euclidean geometry, as instated by the Greek mathematician Euclid 3 centuries before the start of the Christian era. And Euclid is said to have systematized and formalized the predominantly pragmatic approach to geometrical challenges of his time via the geometry of ellipses as described by his Greek contemporary and fellow mathematician Apollonius of Perga, down to the 17th century German astronomer Johannes Kepler. Kepler, riding the wave of his discovery of the elliptical nature of planetary orbits, stumbled onto a means to validate the elliptical theory of Apollonius, which, according to historians, apparently had originally been formulated as a strictly hypothetical exercise. Riemannian geometry, so named after its creator, the 19th century German mathematician Georg Friedrich Bernhard Riemann, as a system was originally devised to find inconsistencies in Euclidean geometry. But the enterprise resulted in the founding of a new and independent approach to geometry. Riemann's endeavors culminated in the discovery of relativity by Albert Einstein, who concluded that from the point of view of both the observer and that which is being observed, apparently the shape of space conforms to Riemannian geometry. That is to say that space is curved. The path of mathematical reasoning as a formal system to guide the initiated believer to mathematical truth set in the elegantly shaped and polished stone of the tabernacle of the temple of divine mathematics involves the acceptance of axioms, the application of copious amounts of abductive and deductive reasoning, and the postulation and subsequent proof of theorems. Axioms, be they of the logical or non-logical kind, are basic mathematical statements that serve as the starting point for a given mathematical road trip or theorem of coherent and relevant follow-up statements, and they are the conveniently unproven gatekeepers to the mathematical universe. To avoid getting stuck in the cul-de-sac of infinite regress, axioms were and are assumed to be self-evident and universally binding, exempting them from the burden of proof ad nauseam. In order to qualify as such, axioms are traditionally required to be autonomous, to prevent one axiom being derived from another, consistent, to disallow the deduction of diametrically opposed conclusions, fruitful, the smallest set of axioms for the greatest number of theorems, and simple, in order to please the Right Honourable Friar William of Ockham, aka Billy the Razor. Conjectures, on the other hand, are propositions or statements that show initial viability in being presumed to be genuine and true, but lack solid proof at a later stage without necessarily being faulted irreversibly. Apparently, conjectures have also been known to occasionally morph into independent hypotheses, stronger assumptions taken to be true for the sake of argument, depending on the frequency with which they are called upon to support promising cases of conditional mathematical proof. Technically speaking, mathematical proof is established from when a theorem can demonstrably be extracted from relevant axioms. And vibrating in unison with the process of theorem extraction, in order to further substantiate mathematical proof, is its apparent quality of imperviousness to differences in the tactics, techniques, and procedures of random practitioners of high mathematics. This is a more fancy way of saying that your personal opinions and beliefs are assumed to not noticeably upset the proof with its ironclad deductive focus and saturated aura of mathematical certainty. Although any logical sequence of statements leading to a theorem may count as proof, advanced mathematicians typically seek proof of the clear, economical, insightful, and elegant kind, which is where a passion for pursuing mathematically sound lines of reasoning, creative imagination, and subject-specific intuitions come into the equation. And, wait for it, Occam's razor too. So this is a section of the chapter about mathematics, which is chapter number 10 of my essay, of which again you can find the full text on my WordPress blog, erikvandepoel.wordpress.com. I hope you enjoyed this. There's lots more good stuff in the full text. For now, thank you for watching. If you have questions and comments, please leave them in the comment section. If you liked what you just heard, please be sure to like and subscribe to my channel. Again, thank you for watching. I hope I will see you again soon. My name is Erik van der Poel. Bye bye.